Welcome all to my 10th lecture, Understanding of Pointers. So these are the main topics which we'll discuss in today's lecture. So pointer is one of the toughest topic to understand for, for whole non-CS background students. So here my intention is try to show, make you people understand with some small and simple examples and try to slowly increase your knowledge on pointers. So first of all, what is an integer or char or struct data type? So these are all different data types which stores a value in a particular address location. When you declare a variable index, int is the data type, x is the variable name, and value you are assigning. When you try to assign the value, we are not really worried or we are not bothered about the address location. And once you link it in the linker command file for a global initialized variables, it will go to CINIT, and then you can decide if it is if you want to have a program which has to be work as a standalone, you should store this .CINIT variables in flash memory. Or if you don't want to have it as a standalone, then you should have stored you should store this .CINIT variable in some RAM location. So if you do not watch my previous video, I highly recommend you to watch patiently my videos right from the starting. So now let's get back to the topic. So what is a pointer? Pointer is it's a data type. It's a variable which will store the address of a particular data type. The type of the pointer depends on which data type does the pointer points to. So what is this int star p means? What is this int? Int means it is saying that it will point, it is a pointer to an integer. So it should point to an integer variable. That is what it means. A pointer variable always store the address of the same data type. It cannot store the address of a different data type. What I'm trying to say is, if you have a unsigned int, and then if you try to unsigned x variable, and then if you have an int star p, so it will not work. If it's an int star p, then it should store the address of an integer variable, not any other data type variable other than integer. So if it is a struct number star p, then p should hold the address of a structure which is of the type number. I'll try to show you with some examples. So let's assume that you are having a structure which is having two elements of 32-bit each, n1 and n2. So the moment you try to type def number num, so what does it mean? This number is the data type, of user defined data type, and then this star p. So it's very well normally when you write the data type and then space pointer, so this is also the same. The number is the data type. So now the pointer should have the same data type. So the num as well as the number. Num as well as the pointer is having the data type called as number. Then basically it can try to store the address, right? So if you want some variable which should store the starting address of the structure, this pointer should be of the same data type. That is nothing but number, right? So if you try to store, like this, so let's assume that you are having some address location 8000. So it will try to show the LSB first. Each location stores 1 byte of data, right? So if it is a 32-bit or 32-bit data, so it will have basically 4 bytes. So you can see the 4 bytes and then the next 4 bytes. But one thing what you want to understand is the structure. If you have some 32-bit 5 elements, 10 elements, whatever the elements it is, it will only store the start address of the element, and which will be basically a 4 bytes of address location. Please note a single pointer variable always stores 4 bytes of address location to store the start address of the element. So if you have some 8000, then basically like the 00, the LSB part will be stored in the starting location, and then followed by 80. I'm not showing the other like 16-bit, so that is the reason why you are able to see, or like basically these are all before bits are 0, so that is the reason why you are able to see 00. So always the structure just uses 4 bytes to store like only it takes 4 bytes of address to store the address of the element, whatever it may be. If it is an int, character, like structure pointer, where the structure or union which consists of so many elements, it will only store the start address of the element. Let's try to understand with some examples, basic examples to start with. Let's assume we are having like unsigned 16-bit variables ABC. I am having a pointer like which is also a type unsigned 16-bit pointer variable P. Now I can pass the address of A to P, because both variables are having the 16 like unsigned 16-bit integer data type, right? So this is the basic pointer data type, where you will have like a simple pointer variable of some simple data type, and then you can pass the address of any 16-bit integer value. So the data type should be the same, right? So you cannot pass the 32-bit pointer variable cannot be used to store the 16-bit integers address. So then the compiler will give you some error. The compiler will give you some error, right? So it says that it is incompatible pointer data type, right? So now let's get into the next next example. So in the next example, let's try to talk about like referencing and dereferencing of pointers first. So what is referencing? Referencing a pointer means assigning a memory address to the pointer variable. This allows the pointer to act as a reference to the variable's memory location. So you are referring something, right? So that is what referencing means. So when you try to pass the address to a pointer variable, so you are trying to say that it is referring to some address location. So that is the meaning of referencing. And then when you try to write star ptr is equal to 20, basically this is called as dereferencing, changing the value at the num address to 20. So what we are trying to do is, whatever the value which is stored by the pointer in that address location, the value we are trying to change. So that is what the dereferencing means. You are trying to dereference the pointer. So now let's get into the next topic, that is the arrow operator while using pointer variables. Let's assume that you are having some structure in this format, number, and then you are creating a num variable which is of data type number. We are trying to create a pointer which is also having a data type of number. Now you can pass the address of num to the pointer. So you can see here the pointer is having the address of num variable, and num is having some values in its memory location. Now, if you want to write some value to the memory location, we should use dereferencing. So before we discussed about dereferencing. So if we write star pointer dot n1, so if you try to write star pointer dot n1, let's assume that you are trying to write like this. The precedence of dot is higher than star. So what does it does is, the compiler will not see the star first. The pointer first evaluates pointer dot n1, and then it will take star. So what if you're not putting the parenthesis around this, and if you try to just write star pointer dot n1, eventually the compiler will take it, it has in this format star pointer.n1, which means which means pointer.n1, if it is there is some address, then the value stored in this address can be dereferenced, but that is not the case, right? Because this is a value, so this is basically a syntax error. Our intention is to write the value in num.n1. Hence, when we write, what we should do is first we should dereference the pointer first. Means the pointer is we took the pointer variable. So the address which is stored in the pointer is dereferenced by putting a parenthesis first. So the precedence is for parenthesis. So we have dereferenced it. Once you dereference, then you can write the value to the to this particular sub-element n1. So the arrow operator is nothing but it is a replacement. Like rather than putting star parenthesis, you can simply replace it is by an arrow operator. So that is the purpose of arrow operator. In the next few minutes, I'll try to show you a practical example of this as well. The next topic what I want to discuss is regarding the call by reference for an integrator function. So I'll try to show you this call by value. I will try to take the example of some previous lecture, call by value, and then we will also talk about call by reference, right? So let's get into the example. So in the previous lecture, we made a structure called as integrator, which consists of sampling time, previous output signal, present output signal value, and then the input signal value. And also we have discussed in the previous lecture, how do we arrive at some formula given by the present input signal into the sampling time plus the previous value. And then we try to show you some example, right? So let's try to take up this example. So we created an variable called as input voltage, which is of data type integrator. We have assigned some initialization directly here. And then we are having a function called integrator function. We are calling this function and we are passing the input voltage to this function, right? When you try to call here, what we are trying to do is we are just passing the copy of the value to this function. Then whatever you modify inside this function it will stay within this function. It will not affect the whatever the argument you are passing to this function. So that is nothing but call by reference. Then you are returning this input voltage dot present output signal, and then you are assigning that value to the the previous output signal. So this you are trying to do here, and then we have we have seen the value, the value will get updated. So let's try to verify this again once again. I'll try to just debug it. So we are just passing some, we are just doing some integration. Yes, now let's try to run it, and then and then I think already you can see the value is 0.99.34. Now what I'll do is I'll try to modify this function. What I'll do is I'll try to create a pointer. I will try to create a pointer variable which is of data type, which is having data type of integrator. Now what I can do is I can pass the pointer. I can pass the address of the whole structure. I'll try to do that. So the address is passed to a pointer variable, right? Now what I'll do is I'll try to pass the address of this, I'll try to pass the address to the function. We are not passing the value and passing the address. So this is nothing but the address of value is passed to a function, right? Now what I'll do is whenever you pass the address, the whatever the signal which is taking should be a pointer. and it should be of same data type. So that is the reason why we're having the integrator. Now when you have this, now like as I discussed, either you can use this arrow operator because you want to like access the value which is stored in that memory location. So you are having the pointer, you have to dereference the pointer. So the address you got it, and then you are trying to access the element, right? So now I can just put the whole like I can replace this dot by arrow operator, right? Then one more thing, what you want to do is this whatever the value what we are calculating for this present output signal that you want to pass to it's like it should the previous value should get updated. So I'll just do this as well. Yes, here also, and it should be the arrow operator, right? Now there is no need of any return, like there is no need of any function return, because when you have an integrator and you are passing the address, so basically you're trying to directly refer to the address, and then directly the values shall be updated. Then there is no need of passing the return data return value to the function. So that is one of the advantage of the pointer. So if you have a pointer, so normally if you see a function can only return one single data type, but like when you use a pointer, like you can update simultaneously multiple values inside the function itself, right? Now I'll go to main.h. I'll try to this is this is now my new function declaration. So I'll try to update here as well, and then now I'll just try to save it. Here also I saved it. So yeah, now this should work. So I'll try to explain here once again. I've just created a I just created a pointer which is of same data type. That is the pre-request. Okay, I have done that. Now like I can just pass this pointer or like input voltage, both are same. I can do this as well. It's absolutely no use. You are just passing the address. So the pointer is having the address. Now whenever the function like the whatever the argument which is coming, so you are passing the address. So the address only shall be accepted by the pointer. Now the pointer should have the same data type, right? So I just created the data type integrator itself. I cannot have float in unsigned 32 or something. It should have the same data type. So this also we have discussed. Now let's try to compile this program called by reference, and then let's try to let's try to run or debug the program. So I'll try to run the program now. So we should be able to see the value of like some 0.99, whatever we have seen for the call by value, we should be able to see here as well. So yeah, we can see that. Yeah, now you can see that like there is no need of any return of the function. It's directly getting updated in the function itself. So that is the advantage of called by reference. So we'll see more and more examples in the next lecture, more into structures. See you all in the next video. Thank you.